Hi, this is Lady Emmanuel. Guys, today we're solving system linear equations with two variables using the substitution method. I would like to remind you of the kind of answers you may derive. So here we go. It's three possible solutions. The three possible solutions, I'm going to just slide this up, pause it, read it, write it down. One solution, you're going to give me an order pair, the x and the y value. If it's infinite many solutions, you just say infinite many solution or just our real numbers. If it's no solution, it's going to be empty set. Since we're doing this algebraically, what's going to happen, we're going to end up with variable equal statement, meaning we'll end up with x equals a value, y equals a value. Or we're going to end up with true statements or false statement. Okay, true statements, the solution will be infinitely many solutions. If we end up with a false statement, it will be the empty set, no solution. Okay? This you're used to variable equal statement. The x equals a number, y equals a number. Okay, so let's do this. Let's get our practice on. Make sure you are listening to the video, write down information, and make sure you understand it. You're taking ownership of your learning. So the first problem that we're going to do would be y equals 5x plus 1 and 4x plus y equals 10. This is our system of linear equation. Notice it is two equations. And I like to number my equations. Okay, just for myself, I'm going to number this one 1 and this one 2. Okay, when you're using the substitution method, you want to isolate one variable, meaning get either y by itself or x by itself if necessary. In this case, notice we already have y by itself. So if y is by itself, that's what I'm going to substitute into the other equation. Okay, so here we go. Since one I already have y solved for it, I'm going to take the second equation. I'm going to rewrite it. I'm going to write the second equation so I can know which equation I used. I'm going to write 4x plus y equals 10. Write the original. Now I'm going to substitute in. So it says y equals 5x plus 1. So in this equation, instead of writing y, I'm going to write 5x plus 1. So 4x, just bring that term down, write plus. Since that's a plus, I'm just going to write down 5x plus 1. Put it in parentheses. Equals 10. Because in order for me to solve for the variable x, now I could actually solve for x because I have one term. Here I have an x term and a y term. I just have one variable, x variable and x variable, so that means I can combine like terms. When you have parentheses and you have a plus, just drop the parentheses or you can sort of ignore it. So I'm going to say 4x plus 5x, those are like terms, plus 1 equals 10. The sum of 4x and 5x is 9x plus 1 equals 10. So what I'm doing now, I'm trying to isolate the x, solve for x, so that I can have the value of x. Okay, so in the next step is just solving two-step equation right here. Subtract 1 from both sides. That cancel because they're opposite, they're at the inverse. I'm left with the 9x on the left. The sum of 10 and negative 1 is 9. I'm not done because I haven't isolated x yet. It still have a coefficient of 9, and I need the coefficient to be 1. So I'm going to divide both sides by the coefficient 9. 9 divided by 9 is 1, therefore it cancels out, leaving me with 1x equals 9 divided by 9 is 1. Okay. So my x value is 1. Okay. Now I'm going to take this 1 and I can substitute it in the first equation to get the y value because y is already by itself. So I'm going to write number 1 and I'm going to write y equals 5x plus 1. Bring down the y, bring down the equals, and put 5 in parentheses for x. Instead of writing x, I'm going to write the value 1 and I'm going to put plus 1. So now I'm going to say 5 times 1 is 5. Bring down my plus 1, follow the order of operation here. Then the sum of 5 and 1 is 6. Now I have x is 1 and y is 6. Do I need to check? I'm going to check. If I did this correct, and this is the solution to this system, it would make both the first equation and the second equation true. So let's check. Okay, so I'm going to actually check by I'm going to just check. So let me write down check. So here I got y equals 5x plus 1. For y, I got 6, so I'm going to substitute 6 in here. Bring down my equal sign. 5 times x, I got 1 plus 1. Okay, so now I'm going to say 5 times 1 is 5 plus 1. Bring my 6 down. 5 plus 1 is 6. I got it is 6 equals 6, so I did that correct. It works for this equation. Now I got to check the second equation to verify, to make sure the solution is correct. So with the second equation, I'm going to write 4 times x plus y equals 10. I'm going to substitute in 1 for the x plus 6 for y. And I should get 10. 4 times 1 is 4. 4 plus 6. 4 plus 6 is 10. 10 equals 10. That checked to be true. Okay? So this solution to this system would be 1, 6. So the point of intersection is 1, 6. I'm done. Okay? That's example 1. The rest of the examples I'm not going to check, but I highly suggest that you check yourself. Okay? And make sure I don't make any mistakes. Hint, hint. I may make one. Okay? So example 2. And guys, remember, since it's a video, you are allowed to stop, rewind, slow me down. You can slow my voice down. 3x minus 2 and y equals 2x minus 5. Okay, here's the equation. Here's the equation. We have 2. That's my system. Notice the difference. Here, in example 1, we had 1 that's in slope-intercept form. Then we had 1 equation in standard form. For this system, both of those are in slope-intercept form. Okay, so basically, I don't have to decide what I'm going to solve for. I'm not going to solve for x since I already have my y's. I'm like, hey, just make it easier. So what I'm going to do is say, okay, it doesn't matter which one I use to substitute in. They're saying that y equals 3x minus 2 and y equals 2x minus 5. So they're telling me that I can set these two equals to each other because I will be substituting in for the y. Okay, so I'm going to just write down, when you have cases like this, just write down 3x minus 2, whatever your expression is on the right, and set it equals to the other expression that the variable is equal to. And I write 2x minus 5. Okay, so look, this is y equals y. Both of they equals the same thing. 3x minus 2, that's y. 2x minus 5, that's y. So I substitute it in. So now the objective is to get the x terms on one side and the constant on the other side. So first, let's move the 2x to the left side. So I'm going to subtract both sides by 2x. This cancel. 3x minus 2x is just x. Minus 2 equals negative 5, since that's subtract 5. Then I'm going to add 2 to both sides. Add versus 0. Bring down my x. Bring down my equals. Negative 5 plus 2 is negative 3. And I'm done. Okay. Notice on this one, I didn't number this one, the first equation. And I didn't because both of them